All right, so we've been talking about equation form, standard form, vertex form, and intercept form. And we're going to work a little bit on taking those forms and taking our algebra and relating it to quadratic equations and terminology. So basically some more quadratic equation practice. And we're just going to work through some examples here together to look at that, and then you're going to do some practice as well. So first question, determine the zeros of each equation. Should be automatic at this point, but when you see the term zeros, you should know that means x-intercepts. And when you think of the term x-intercepts, the x-intercepts come from the factors. So if they come from the factors, then you want to make sure that your equation is in factored form, or it's called also intercept form. And if you look at the first three, I've made your job easy for you because they all have brackets. And if they have brackets, that means they're already in factored form. So all you need to do is look at each equation and the zeros are staring at you. You just have to say the opposite signs. So x minus 6 means it has an x-intercept of 6 and negative 2. So it crosses the x-axis, if you're thinking about a picture, at positive 6 and negative 2. That's what it means to the graph. If I look at this one, it's a little bit different. It has a bracket squared, but if you think about what that means, it really means you've just got two of the same brackets, which means we can still look at our brackets for our x-intercepts, except this time because the brackets are the same, the x-intercept is the same. So there's really just one x-intercept of 4. What that means, if you're thinking about an x-intercept, is it crosses the x-axis at 4. So a normal parabola, quadratic, because everything we've been dealing with is quadratics, if it has two x-intercepts, would look something like that. If it has one x-intercept, that would mean that its vertex is right there on the x-axis. So keep that in mind. And then C is a little trickier. It's got a couple of x's, but only one of them has a number with it. Well, that one's easy. If it's plus 7, that means the x-intercept's a negative 7. But this crazy x right here also tells us something about x-intercepts. If there is no number added or subtracted, that really just means you're adding or subtracting 0. So we have an x-intercept of negative 7, but we also have an x-intercept of 0 because there's nothing added or subtracted to that x. So there's two x-intercepts, negative 7 and 0, just like the first one had two x-intercepts. So easy peasy. Zeros mean x-intercepts, mean factors, mean I want to make sure it's in factored form. Let's take a look at the second little question here. Express each equation in intercept form. All right, so intercept form, as soon as I see that, means factored form. Factored form means I have to factor. So I have to take what I know about factoring and apply it here. So if I'm going to apply it here, that means I'm looking for two numbers that multiply to get 2 and add up to get negative 3. So my factors are always the same. We've got x at the beginning, multiplies to get 2 and adds up to get negative 3. The better you are with the times tables, the faster you come up with that. So if I look at B, I have got no x term. So there's nothing I'm adding. So I'm still looking for two things that multiply to get negative 36, but this time they have to add up to get 0. So if you have done your factoring practice, you'll pretty quickly know that they'll be the same number, just one will be positive and one will be negative. So when we express each in intercept or factored form, that allows us, once the equations are factored, the next step, even though we weren't asked to do it, would be we know our x-intercepts from our factors. And remember, the x-intercepts are also called the zeros. So if I look at these last two, they're not quite as nice to factor, but that's okay. This guy can look at him a couple of ways. I could look at him, he's got an x term but no number at the end, so that's kind of like adding 0. So I want something that multiplies to 0 or adds up to 6. So if something multiplies to 0, well, it has to be 0 times something. And if it's going to add up to 6, well, I'd have to have 0 plus 6. And we talked about, when we were doing these in class, how x plus 0 is just x. Now, other way to look at this, yes, it's like a trinomial, but it could also be common factored. You could also look at this like a common factor of x. And just at the very beginning, think, hey, each term has a common x, so I'm going to divide each term by x, and I can factor it that way as well. And the last one is more like a common factoring question because of that number in front. Both of those will divide by 3, but they each also have an x. So they have a common factor of 3x. And I'll divide each term by 3x. The first one leaves x. The second one leaves 4. So now they're all in intercept form. And the ability to factor allows you to put an equation in intercept form, which tells you where a graph crosses the x-axis, and it also will help us with our word problems later on. All right, third question. Determine the zeros for each quadratic function. We already talked about this. As soon as you see the term zeros, you're thinking x-intercept. As soon as you see the term x-intercept, you should be thinking factors. And I look at these two equations and there are no brackets. Therefore, I need to factor. So there's no brackets in the question. Therefore, we need to use our algebra skills and factor. All right, so I'm looking for what multiplies to get 6, adds up to get 5, and we should have plus 3 plus 2. And once I know that, I know my x-intercepts are minus 3 and minus 2. And if I do B, ooh, looks like it has a common factor, this one. It's not the same as A. Common factor, and they both have an x. So that would leave me with x when I divide, and negative 8 divided by 0.5 would be plus 16. So my x-intercepts would be negative 16 and 0. Don't forget the 0 because there's nothing added to that x, so it has a 0 as an x-intercept. Okay, easy peasy. Let's try something that's a little more challenging. Determine the zeros for the following equations. Well, that doesn't sound so bad because we know that zeros are x-intercepts. That means I need factors, so I have to factor the equation. So I'm going to look at my little equation, and I'm going to see what multiplies to negative 11 and adds to 8. But there's a problem. The problem is that there's nothing that multiplies to negative 11 and adds to 8. So the question is, what happens if you can't factor? So you're in a bit of a conundrum. If you can't factor, the factors tell us the x-intercepts, and the x-intercepts tell us or come from the brackets, and if we can't get the brackets, then we're out of luck. So fortunately, there's a handy dandy little formula. That formula is called the quadratic formula. Not very creative, us mathematicians. Quadratic equation, quadratic formula. You use the quadratic formula when you cannot factor something and it will find the x-intercepts for you. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. And you might be wondering what these a's, b's, and c's are. Remember way back at the beginning when we talked about standard form. Ax squared bx plus c. The a is the number with x squared, the b is the number with x, and c is the number at the end. So when I can't factor, I'm going to use the quadratic formula. So this is my b number, this is my a number, this is my c number. If there's no number, remember in math, we're just too lazy to write down the 1. So if there's no number written down, it's 1. Trick as well, make sure that you keep the signs as usual with algebra with the number. So my b number is 8, and the formula says negative whatever b is. So I'm going to have negative 8. Plus or minus means I have 2 calculations. That gives me my 2 x-intercepts, just like my 2 brackets gave me my 2 x-intercepts. One calculation I will add, one calculation I will subtract, and I'll get 2 different answers. And then I take the square root of the number for b squared minus 4 times the number for a times the number for c. Remember, it's negative 11. And I divide all of that by 2 times the a number. So now it comes time to do some calculating. Negative 8 plus or minus, and I'm going to figure out what that number is under the square root sign. So let me grab my calculator just so I don't make a mistake. And I've got my calculator not cooperating. 4. I have 108 under the root sign. I'm just going to double check because I hate to tell you the wrong number. Yep. All right. So then we get to do 2 calculations. Negative 8 plus the square root of 108 divided by 2. And we get to do negative 8 minus the square root of 108 divided by 2, so that we get 2 x-intercepts. Be careful to calculate this correctly. You have to do one of 2 things if you're using your calculator. You either have to put brackets around the numerator before you divide, or you have to hit equals and then divide. Either way, you have to get the answer to the numerator, the answer to the top, and then divide by 2. So let me just get my calculator going. Oh dear, that one's not working. I gotta grab another calculator. All right, so I have negative 8 plus the square root of 108, and I'm going to get my answer to that, and then I'm going to divide by 2. And you will generally have a decimal when you're doing this. And I did not tell you what round it to. Usually if you round it to 1 decimal place, you're all right. So I've got 1.2 for that one. And then if I do negative 8 minus the square root of 108 divided by 2, I'm going to get negative 9.2. So I can get my 2 x-intercepts when I cannot factor by using this lovely little quadratic formula. You will not need to memorize the formula. I will give it to you on the test, but you do need to know how to use it. So signs are important. Don't forget the signs, and then calculating an order of operations. We'll do 2 examples together, and then you're going to do some practice. So my quadratic formula, my A, my B, and my C. So I have negative whatever B is, plus or minus the square root of B squared minus 4 times the A number times the C number. Oh yeah, I kind of skipped over the fact that this one didn't factor. That's kind of the point to these 2 examples. And then I'm gonna do 2 times 2. So we'll do the work under the root sign and figure out what that number is. 4 times 2 times 65. 5 over 4. And then we're going to get our two answers. One of them, I will add the square root of 65 and divide by 4. And to get the second one, I will subtract the square root of 65 and divide by 4. So then I get -3 plus the square root of 65 divided by 4. So one of my x-intercepts is 1.3. Now I'm going to do -3 minus the square root of 65. Get the answer to that. Divide by 4. And the other one is -2.8. So there are my two x-intercepts where the graph crosses the x-axis. We'll do one more for practice. My A is 1, my B is -5, my C is +1. So negative B, whoa, I already have a negative number and the formula is negative. Two negatives are going to make that positive. And then I've got my plus or minus B squared over 2 times 1. So we'll tidy this up. That negative from the formula and the negative from the number makes that 5 positive. We'll figure out the number under the root sign. 21. Divide by 2. And then we'll get our two x-intercepts, one from adding and dividing, and one from subtracting and dividing. So 5 plus square root of 21 equals that, divided by 2, gives me 4.8. And 5 minus square root of 21 is that, divided by 2, gives me 0.2. So the point of this was to review the idea of zeros and x-intercepts in equation form, and then to learn what happens if we cannot factor, and learn that we can still find our x-intercepts if we can't factor.